Hi, in this third video on forces we're going to be looking at terminal velocity and the forces involved when an object is falling with terminal velocity. Let's look at learning outcomes and we'll see what we're going to do with this. So it's these two here: explanation in terms of forces of an object moving with terminal velocity, and then interpretation of velocity time graphs for a falling object. Now we did both of these two in National 5 Physics, and so I'm not going to spend too much time doing this, and this will be really more of a recap from National 5. Now, if we start skydiver jumping out of a hot air balloon, the hot air balloon is just hovering. I don't want any horizontal velocities involved in this. It'll just make it easier to understand. So we have our skydiver has just this instant jumped out of a hot air balloon and is going to start falling. So what are the forces acting on him at the moment? Well, the only force that he will be experiencing at this point is going to be weight. And so the weight is going to cause him to accelerate downwards. The unbalanced force at this point will be entirely weight. So fun is going to equal weight at that point. As a brief amount of time passes, so he's going to be down at this point. Now he's starting to accelerate. At the start, let's just say his velocity is 0. Sometime later now he's moving down. His velocity, let's just say 10 meters per second. So approximately a second later he's moving down. Now his weight is going to be unchanged and his weight will be unchanged throughout. But as he starts speeding up, he's going to start encountering air resistance. So I'm just going to call this friction. I'm going to just use V. So let's just say F, friction. So friction is going to start to act on him, and this is going to start to reduce the unbalanced force because we now have an opposing force to the weight. So at this point we're going to have fun is going to be weight minus friction. And so the outcome of this, where at this point when the weight was unopposed, his acceleration would have been 9.8 meters per second squared. But now sometime later we're going to have a bit of friction, we're going to have a smaller unbalanced force, and so our acceleration is going to be something less. Let's just call it 8 meters per second squared. Sometime later (30 meters per second). Again, weight will remain unchanged. Friction here is going to increase as the velocity increases, the friction increases. And again, our fun is going to be weight minus friction. Our acceleration, again, will get less and less and less. And this will continue to a point where the weight force and the friction force are balanced. This will happen at around about a velocity of 50 meters per second. So what we have is we have weight at this point is equal to friction, and so fun is going to be equal to 0. Consequently, your acceleration is going to be equal to 0 as well. And this is what would be defined as terminal velocity. So the object at this point is falling at terminal velocity. Newton's first law will apply. The weight force is balanced by the frictional force. Okay, if we look at a velocity time graph of what's going on here. So when the skydiver first jumps out, we're going to have a velocity of 0. you should remember that the gradient of a line in a velocity time graph is equal to acceleration. So when the skydiver first jumps out with an acceleration of 9.8, we're going to have a gradient of 9.8 meters per second squared, or a gradient of 9.8. And as they're falling, the acceleration is getting less and less and less. And so what we're looking at is that as time progresses, we're going to have a scenario like this, where we're going to have a curve. We're having a non-constant acceleration. I know I keep banging on about it higher, we're only going to deal with constant accelerations. This is a descriptive thing. We're not actually going to do any calculations involving this, and so we'll get away with it. But you can see that the gradient of this line is decreasing, and this signifies that the acceleration of the skydiver is decreasing, and it will continue to decrease until we get to a point of where the velocity of the skydiver is constant and they are moving at a terminal velocity. So at this point here, terminal velocity has been reached. We can say that the forces are balanced, weight is equal to friction, and this will continue. And this can continue for however long. Now sometime later, let's just imagine the skydiver is approaching the ground, moving at terminal velocity, and they open the parachute. So when they open the parachute, suddenly this frictional force becomes much larger. And so now we have a bigger frictional force than weight, and so our fun is going to be friction minus weight. And this will cause an acceleration, but an acceleration in the opposite direction to the motion, or a deceleration. This is going to be really, really large at the start. So if we keep plotting away on our graph, we're going to start having a very, very steep downward gradient. The negative acceleration, or the acceleration against the velocity of the skydiver, is going to lead to a reduction in the velocity, and as velocity reduces, so will friction, and so the opposite thing kind of happens. That if we have there, the friction on the skydiver is going to get less. Again, weight will always remain constant. As the velocity gets less, the friction gets less, the unbalanced force will become less, and therefore the acceleration, or the deceleration will become less, and our graph will start to look like that. And this will continue until a point of where, with the parachute open, your friction will once again balance the weight. And at that point, they will reach a new terminal velocity. And then hopefully that new terminal velocity is low enough that when they do hit the ground, it is a nice landing for them. But that's really free fall or terminal velocity and the forces involved in that. Okay, thanks for watching. Bye.